So, how was your year? Your year was probably tough, but I don't know what you know about tough, but we had a pretty interesting year here at Microsoft because about a year ago, actually a little bit more than a year ago, we released the Windows Virtual Desktop. And the Windows Virtual Desktop is a little bit more than 1 year old. And I know for sure what does it mean to have like 1 year old. So this is my baby girl. She was born like 2 days before Windows Virtual Desktop was released to GA. And I was following both her and Windows Virtual Desktop pretty closely because I see them both every day. And she's over 1 year old, as well as the Windows Virtual Desktop. And what we did in the past year, not with my baby girl, but with Windows Virtual Desktop, is pretty amazing. I will try to keep it less sales and more technical. So I will stop using word amazing, but I hope you will use it more than me when you're watching this and listen to this presentation. So we did a lot of things during the past year, and we were focusing on several aspects such as security, usability, cost reduction for the service itself, and the scalability of Windows Virtual Desktop. And it's kind of tough to talk about these things like in a poor technical manner because some of those things sounds pretty salesy, but I will try. So what we have done in the past year is it's pretty good, not amazing, but it's pretty good because we brought the product that was released 1 year ago. We brought it to thousands, a lot of thousands. I probably shouldn't tell the exact number, but there's a lot of customers using it, and we have a lot of daily active users and monthly active users that we count, and the results are actually so surprising. We had at some point of time during this year we had like issues like do we have enough capacity to run Windows Virtual Desktop on Azure? And we actually have, so that's a good thing. But besides just scaling the service and running the service for all of the users, we were working on improving it and adding new features. And some of the features that I'm going to talk about are released already. Some of them were announced during the Ignite. And I will try to describe those features from the technical perspective. What does it mean and how you can use it. So let's start. So on the security part, we added a few things to Windows Virtual Desktop. First of all, we as you know, we have Windows Virtual Desktop as a service, and this service supports multiple operating systems. And those operating systems are starting from Windows 7, and it can be Windows Server, it can be Windows 10, obviously. And there's one thing that many people still call Windows Virtual Desktop or Enterprise Virtual Desktop (EVD). It's Windows 10 multi-session, and Windows 10 multi-session is a great operating system, and we see this from our statistics and from our telemetry that majority of Windows Virtual Desktop deployments are using Windows 10 multi-session, and surprisingly, it is also used as an operating system for personal desktops. And when we're talking about this operating system, we understand that it's a core operating system for Windows Virtual Desktop, and it should work as people expected, and as an operating system that is actually like quite an operating system, and it should be managed as a client operating system and support all the functionality. And initially, when we released Windows 10 multi-session for Windows Virtual Desktop, there was some issues because it's kind of like a mix of the client operating system with RDSH server. So some of the functionality that is targeted for Windows 10 wasn't working on Windows 10 multi-session. And the compatibility story for Windows 10 multi-session is one of the core things that we're trying to focus on. And we improve this compatibility by adding support for Windows Defender ATP. So you can use all of the Azure policies for Windows Defender, and you can also use the policies for from Azure Security Center to manage and control the security of your Windows 10 multi-session environments. So Windows 10 multi-session basically is supported for all the functionality that is available for security on Azure. Another thing that we added recently to Windows 10, to Windows Virtual Desktop is the functionality that you can use in when you configure Azure Firewall. So since the first days of the Windows Virtual Desktop release, customers were asking us. Many customers have a really strict security environments, and they have the firewalls that control access to the internet. And they were asking us what kind of firewall rules we should configure, what are the IP addresses of Windows Virtual Desktop infrastructure that needs to be configured, what we should configure on the firewalls. And the answer was like, oh, you should configure the FQDN, and the customers were saying like, oh, our firewalls are stupid. They don't work with DNS names. Could you give us a list of IP addresses? And we were saying like, oh, you know, we have like pretty dynamic servers that have a lot of IP addresses that are changing like daily and unpredictable. So for a few months before we released the Spring update for Windows Virtual Desktop, a lot of customers were blocked in their deployments because they were not able to configure their firewalls. And what we did to resolve this, we added a new service tag that you can use when you configure in Windows, Azure Firewall or Azure Security, Azure Network Security Groups. And you basically configure that you allow access from your Windows Virtual Desktop VNet to the Windows Virtual Desktop infrastructure by configuring the service tag. And that's it. It's pretty easy. So I hope that we unblock the customers. So another thing that we were working on. So when Windows Virtual Desktop was in the preview, it was running in 1 or 2 regions in US. And since that time, we were increasing the capacity of the service, and we were bringing the infrastructure services to other regions. And this is really important because bringing the services to closer to the actual end users helps to reduce the latency, helps to reduce the connection time, and improve the user experience. And we were bringing the service closer to every region, and the work on this is always going on, and we are bringing service to new regions like almost every month. We brought Windows Virtual Desktop to some of the sovereign clouds, and we brought it to US sovereign clouds and the Gulf clouds. And the work for other regions is going on. And just to like give you understanding how it works, how it happens in the background. So imagine like like how you can scale the service. Like when I was trying to build some kind of similar infrastructure about like 7 years ago, and I was doing this with Citrix and running this on AWS, but it was kind of similar. I was deploying each server, like each Netscaler and each as an app server manually as a virtual machine. But well, when I was starting this, yeah, it was like manual deployment. The next thing that I did, I created some templates. And it was pretty complicated, but still was like scalable a little bit. You can't imagine how the Windows Virtual Desktop infrastructure is scaled. So developers are, when we need to add additional regions, developers are actually just typing this in the configuration that we are adding additional region, and the deployment and the clusters are deployed by the service deployment service, and it's pretty amazing how this infrastructure for Windows Virtual Desktop was built. From the technical perspective, I wish I can share some of the screenshots or some of the information from internal systems, how this stuff is deployed, but unfortunately I can't. But it's amazing. You gotta believe me. So the next thing that we added support for Windows Microsoft Endpoint Manager, or Intune. And this support is pretty important because we have a lot of customers that are using Microsoft applications like Microsoft Office, and with this integration with Microsoft Endpoint Manager, you can deploy the Office, you can deploy some other applications, and you can like pre-configure them exactly the same like you can do this for your physical desktops. But it's nice to know that Windows Virtual Desktop acts like a physical desktop. That's actually our goal, to make Windows Virtual Desktop as close as possible to the physical desktop. And yeah, you can assign the applications, you can control the endpoint security policies, you can pull the reports from the Microsoft Endpoint Manager, and it's pretty cool. Another thing that is coming, it's not released yet, but it's kind of thing on the roadmap that was announced recently during the Ignite session, is support for single sign-on with ADFS. So there was some chats on the Twitter, let's call them chats, regarding the single sign-on on Windows Virtual Desktop. And as you probably know, if you ever use Windows Virtual Desktop, you need to enter your credentials twice. The first time you enter them when you authenticate to the client itself, and the next time you enter your credentials when you connect to the VM. There was like a lot of discussions internally, like is it okay, what we can do with this, and we thought about some like temporary workarounds, like other folks in the industry do when they cache the password that you type, and then they just pass it to different systems like silently. And even we considered that, we decided that it's not right. And we year ago, we decided to release the service without single sign-on. There was a single sign-on for ADFS, and it was kind of working, but not really like supported. And now we are bringing single sign-on support for the new Windows Virtual Desktop service. That's the Spring edition, and it's coming soon. Another feature that is coming from the security perspective, and I know about this feature a lot because I'm driving the RDP protocol within Microsoft, and this is one of the features that I'm driving, is screen capture protection. So the screen capture protection is one of those features that many customers are asking in the scenarios when they have untrusted clients like the bring your own device or home PCs, which is extremely popular right now during COVID times. And when we talk about screen capture protection, it's not just protection from the screenshots, because we announced the screen capture protection. There are some other features coming to protect the content of the remote desktop and content of remote session in general. But it's not just a security feature, it's also a convenience feature. In many cases, you probably like been in situations when you have when you trying to join like a Teams session or Skype session or I don't know, GoToMeeting session, and you need to, like suddenly somebody is asking, well, can you share your screen? And you start sharing your screen, and you finding that there are some emails are open and you don't want to share them, and it's already too late. People already made a screenshot of your session. So when we're talking about screen capture protection for Windows Virtual Desktop, it's a feature that protects the window itself. It's not protecting the whole desktop, because the rest of the desktop may run some other applications that shouldn't be protected by default. It is configurable. You can still enforce and use screen capture protection for the full desktop, but by default, it will protect only the content of the session that is that should be protected. And like on the screenshot in the presentation right now, you see that there's like black rectangle. So the black rectangle, it would be your protected session. Another window in the background is a remote desktop session to another host that is not protected. So that's how it would look like when this feature would be released, and we expect to release it early next year. Few features came to Windows Virtual Desktop from the cost protection. So when I'm talking about cost, I don't want to go into discussion how Windows Virtual Desktop is cheaper than everything else, or how it's more effective than your on-prem deployments. You probably know this, or you have your own opinion, and I'm not in position on changing your opinion. But if you are willing to use Windows Virtual Desktop for one reason or another, there are a lot of ways how you can optimize your costs. And one of them is automatic scaling using the Azure automation. When you scale up a number of session hosts that are connected to serving your users. And this feature is already released. You can use Azure Automation. We have a pretty good documentation on how to start with Azure Automation for Windows Virtual Desktop, and you can configure the scaling scripts to have your session hosts scaled up when you need it. But what to do to save costs when nobody needs the VM? So you can obviously shut down your hosts, or your users can power off them. And the last option, when users are actually powering off single session personalized desktops, is kind of like a good generator of support events for the help desk. So to fix that, we are bringing a feature that is called Start VM on Connect, or SVMonk, as some people call it. So SVMonk will start your VM when user tries to connect, and that's basically it. You enable it on the session host on the host pool properties page in Azure portal, and that's it. Your VM would start when user tries to connect to it. Usability. So in the past year, we released basically two versions of Windows Virtual Desktop. The first version was exactly the same like the preview was, and It was great. We had a lot of customers, and we got attention about for this service. We got lot of good feedback from customers. But one of those things that got a lot of feedback that, oh, we need the UI. We need the UI. And surprisingly, we knew that you need the UI, and we was building this UI in the background, and it was this UI was based on the proper integration with Azure Portal, with PowerShell, with Azure CLI. So it was basically based on the Azure Resource Manager model, or ARM model. Don't confuse with the processors. And we brought ARM integration for Windows Visual Desktop early this year. And I'm not going to show you the actual screenshots for that because you already seen it. It works. Another thing that I'm not going to talk in details in this presentation is client improvements across all the platforms. So the beauty behind the Windows Visual Desktop, that it's a service that is managed by Microsoft and it's deployed by Microsoft. Remember when I was talking about the regions that we deploy, I told you that developers are actually driving where we deploy this, and developers are actually releasing the code pretty often. If you following the releases for the service, if you're trying to track the version numbers for the service, for the client, for the side-by-side stack components for RD agent, you may notice that some of the components are updated like twice a month. Some of the components updated maybe like once a month, but it's still pretty compared to what it was before, because as you may recall, remote desktop protocol was always part of Windows since Windows 94 Terminal Server Edition. And the only way how you can get like a newer functionality for RDP previously was to install the new Windows version. But with Windows Virtual Desktop, we are building those features and we deploying them much faster. It's not a Windows release. It's not like even the insiders release that are released like once in a few months. When we build updates for the protocol, when we build updates to the service, when we build updates to the clients, we're releasing them, and that's it. You can use them. So the client improvements for the clients we actually have in our documentation webpage. We have, at least for Windows and for Mac client, we have pretty detailed release notes for every release. We describe which features were added, which bugs were fixed, and we had a lot of improvements in the past year for all of the platforms, including we switched the few of the clients to the new SDK that we used to build the clients, the RD Core SDK, the SDK that we used to build all of the clients except Windows and except HTML5. The Windows one is it's a tough story to say, but we plan to bring Windows on RD Core. But in any case, we were developing a lot. Another thing that was brought pretty recently to Windows Virtual Desktop is MSIX App Attach. And we recently announced that we will bring the UI integration for MSIX Attach, MSIX App Attach to the Azure portal. So if you have customers that are not really heavy on the PowerShell, they will be able to do this just with the portal. Another feature that falls under usability, but I would also say that it's more like user experience. Yeah, it's usability, is RDP short paths. So last Monday, we released RDP Short Pass. RDP Short Pass is a new transport for WVD that is based on UDP. And if you followed Twitter, if you followed some of the discussions on Twitter, you've probably seen some heated discussions regarding RDP Short Pass. Before you fall in those discussions, and before you start saying oh, Microsoft is forcing us to use public IPs, or Microsoft is forcing us to use VPNs, I'm begging you, just try to read the documentation. Just because do me a favor, read the documentation. We are not forcing you to use public IPs. We are not forcing you to use VPNs for connectivity. It's one of the options, or a few options that we are supporting if you wish to use it. So just imagine the story. So when we were planning RDP Short Pass, we plan a lot of we have a plan for a lot of the connectivity changes and the protocol changes that will come next year and the year after that. We are working pretty heavily on the network connectivity for Windows Virtual Desktop and for RDP protocol in general. And since we are able to do staged approach for the releases, we're planning what we will release at one point of time and what we will release next. And one of the things that were easy to release was this feature, RDP Short Pass, that is heavily based on the existing functionality that we had with UDP-based transport since Windows 8. And about a few months ago, when we were ready to release this, we were thinking what would be the use case for that? And the primary use case for this feature, based on the design of this feature, was express route. And we said, great, let's call it RDP Short Pass Private, because it would be for the private networks running over the private connection, over private IP addresses, and it's specifically express route. Now, at the same time, you and I know that express route is a great feature that Azure customers can use, but it's just one of the routing configurations that you set up in your routers, and you use BGP routing to route your packets to the Microsoft in one way or compared to another. So it's basically IP connectivity. So how it is different from site-to-site VPN? It's more expensive, you can say. So what we decided, okay, site-to-site VPN is okay. Let's support it. And we were almost ready to test this feature on our internal systems, on our internal environment at Microsoft. And the thing happened, COVID. So the feature that was designed to connect users that are sitting in the office, connect them directly to the VM, this feature was falling apart because we are not able to test it because everybody at Microsoft is sitting at home. So what we should do? Okay, let's try it over the VPN, because many of Microsoft employees are having persistent VPN connection for one reason or another to the CorpNet. So let's try it. Will it work? So we tried it. We found that it works perfectly. It was great. It's not ideal because most of the VPN connections that we had were TCP based, but it was great. And we said to ourselves, why we shouldn't support it for our customers? If it works for Microsoft, then it would work for our customers. Great. So we started supporting the regular VPN client connections. And then we thought, okay, so everybody's sitting at home, and we have some customers that have the urgency to have UDP transport because of their use cases with graphics, etc. And we thought like, okay, what we can do with this? So let customers use any kind of connectivity they can set up. So let's support direct IP connectivity. And that's where we had a lot of like internal discussions. What we should do. The public IP connectivity sounds like a step back from the reverse connect. Many people would think that it's like it's insecure, but the reality is that it's not less secure than your web server that is hosted on the internet. Some web servers can be hacked or defaced, as you probably know. Some web servers are running great because they are protected. And the good thing that Windows Virtual Desktop is running on Azure, so you can have Azure DDoS protection, Azure Firewall, and other things that you can configure. But first of all, you can use your own like brains to think about like how to set up your environment and how to set up your firewalls. So, and it's no different from just like having Windows Virtual Desktop without the short pass function, because we like in every part of our documentation, we're saying that when you set up the Windows Virtual Desktop, do not open the TCP 3389 port to the internet. Do not assign the public IP address because you don't need it. Do not open this port. We still have customers that are doing this. So, okay, let's see how it works. But the thing that you need to understand with short pass that it doesn't replace the reverse connect. I begging you, read the documentation. One of the things that we have released as a part of the documentation for Windows Virtual Desktop for the RDP short pass is the description of how the reverse connect works. The reverse connect, the transport that we have for Windows Virtual Desktop since the first release wasn't really documented in the way how the regular RDP protocol is documented. So this documentation that was released this Monday is actually first attempt to describe how does it work. And I have the screenshot that you see right now that describe like 12 steps on the client side for the reverse connect. So the green, the steps in green that are starting from number 13, they're actually the steps that are added to the reverse connect after reverse connect is established. So RDP short pass doesn't replace reverse connect; it complements it and extend the reverse connect functionality, and it is using the reverse connect for the security negotiation, for the transport handshake, and yeah, that's what you can use. Another piece of the documentation that I really want you to look at is a new page on the bandwidth considerations. So many customers, when they plan Windows Virtual Desktop, they think like, oh, how do I plan the network? And they look into the bandwidth recommendations that we previously had. And those bandwidth recommendations were like, or if you want to watch, like if you have a power user, you probably need to have like 15 megabits per second connectivity for this user. And for many customers, it was like, oh, wow, that's too much. But like some of the customers were asking themselves, like, and what is the power user? What does it mean? Like, what the power user actually do? And there was no easy answer to that. And we were thinking like how to properly describe the actual use cases. And we got the idea to just have the animations for each of the workloads that we are describing. And please go to the documentation page for network connectivity in Windows Virtual Desktop, and you will see that for each scenario, we have bandwidth recommendations. You can call them peak recommendations for the different configurations. And we have animation, the description of what is happening, what kind of full screen video was tested, or what kind of Microsoft Office workloads were tested to measure the bandwidth utilization. And keep in mind that the numbers in this recommendation are like peak numbers for each of the individual workloads. But most of the users, and we see this in the service in real time, most of the users are doing nothing. They are sitting idle, they are drinking coffee, they are, I don't know, they don't do anything most of the time during their days. And they actually using like less than a kilobits, less than 1 kilobit per second for most of the time in their connections. That's just pretty amazing. But why do you need to know the bandwidth considerations? Because with RDP short pass, we started supporting quality of service policies. So quality of service policies is not a new feature. It's been within Windows, I think, starting from Windows 2008, or maybe even from Windows 2003. So there are the group policies that you can configure to support quality of service DHCP markings and traffic shaping or traffic limiting. And I know that some of the customers were using it for regular RDP connections, but not a lot. The good thing that with RDP short pass, you can configure those policies to prioritize the traffic or decrease the priority of the RDP traffic for Windows Virtual Desktop, or you can apply the traffic limiting policies to reduce or limit each session to the specific amount of the bandwidth that is allowed to this user. So if somebody suddenly will start watching YouTube videos, he will watch a slideshow, but the rest of the users on the same MPLS link would be able to work their Excel or Word or PowerPoint. Another feature that we released, not released, but planning to release pretty soon is the migration script for, or migration tool for migration from the classic model of Windows Virtual Desktop that was released a year ago to the ARM-based model. And it is a pretty cool script that is not just like copying the objects or doing something. It's making a hybrid deployment for some period of time that you can test and verify, and then it's like switching over to the new ARM-based model when you decided that everything works as it should. But the cool thing that it doesn't require your users to be disconnected from the session, or it doesn't disconnect the active sessions. It keeps the session host registration, and it's pretty cool because we have a lot of customers that heavily invested in Windows Virtual Desktop when it was released, and they built an automation because at that time there was no like easy way to automate things, and those times were just a year ago. But a lot of customers build their automation scripts. They built a lot of deployments, and to migrate them, they actually need time, and they have a need tool. And we are going to release this tool pretty soon. On the scalability, what we recently added is what we recently announced is support for Azure Monitor for Windows Virtual Desktop. And this will help the IT admins to monitor their WVD deployment and to take actions and to see like if there are some issues that customers are experiencing, they have to fix something. And in many cases, the thing that you need to do is actually like dig deeper into event logs and do some actions. And in fact, I will be honest with you, there are some other tools that can do the monitoring, can do the actions at the same time, and you all know them. And thank you for sponsors of this conference, to Control Up. Now, it's a time for questions. We have exactly, I don't know, 10, 20 minutes, Alex?
Yeah, we have 10 minutes. Now, just a second, I'm gonna start to read the sessions to you. Just 1 second. Right. Okay, so let's begin. So the first question is, do you need hardware to support quality of service on RDP? Or don't we need hardware to support quality of service on RDP?
So why do I hear myself? Okay. So to support quality of service policies, you need to have something that actually act on those policies. So what is quality of service in the network? Quality of service is something marking the packets, the TCP or UDP packets with the IP header, with DHCP marker in the IP header, and then network equipment on the path of this packet is actually taking this mark into account and prioritize the traffic. So basically, you can call it, you can compare it with the carpool or like fast track lanes on the highway, where some cars that are more privileged for one reason or another, because they have more people in this car sitting in the car, or because they have, like, I don't know, something is blinking on the car, they have a fast track. But to get on this fast track, first of all, you need to have like equipment. So you need, first of all, you need to have this like blinking light, and DHCP marking, the QoS policies is adding you this blinking mark. And if people respect it, they will let you in. If your network equipment respect the DHCP markings, it will prioritize the traffic, but you have to set up your network equipment. And one very important thing to understand, if you are new to quality of service policies, just setting up the QoS policy doesn't mean anything. You have to manage all of the network paths. And that's the reason why this feature is coming with RDP short path for express route or other private connections. Because when you run your WVD on over express route or even over the site-to-site VPN, you have control on all of the network elements, on all of the routers, and you can configure them to follow the rules and prioritize the RDP traffic. Now, what happens if you don't have a control? So I have this example, like pretty beautiful example. When I was trying to verify this feature, how does it work if I'm not on the like managed network? I have a Comcast. It's an American internet provider, one of the biggest one. And I found that all of the packets that are coming to my home, they have the lowest DHCP mark. So for all of the residential customers, my internet provider overriding the DHCP mark to have a lowest priority. And for all the traffic that coming out of my home, it also overriding the DHCP mark to the lowest priority, because my internet provider think that commercial customers are having more priority than residential customers. So it doesn't matter what I set, they can override it. So yes, you have to have the hardware support, and you have to control this hardware on your own to have a good quality of service. But traffic limiting is happening within the operating system. So if you just need to limit the bandwidth that is used by each of the RDP sessions, then you can use the same quality of service policies and just ignore DHCP markings and set the traffic limiting policy.